Hello all you crazy people out there, my name is Michael, I like wizards and dragons and making games, and welcome back to the world of unshaded 3D objects. Today we're going to be talking about lighting. So it's been a while since I've talked about lighting in 3D, I've been doing a lot of other things in the meantime. Today we're going to be taking on a somewhat different facet of 3D lighting, and that is the generation of surface normals themselves. So in the past, I have done some videos on 3D lighting in GameMaker under the assumption that any 3D object that you try to draw already has the appropriate surface normals and or vertex normals already built in, whether that be from the model that you load into GameMaker or just from something else. And today it's time to do away with that assumption and jump into the math to do this ourselves. So I will note that pretty much any and all 3D model editing tools that aren't like super ancient will already have functions built in to do this, to generate the surface normals and or vertex normals of your 3D objects for you, and they will be saved when you export in OBJ or FBX or whatever. And for the most part, if you're a 3D artist, you don't have to worry about this, but one, having knowledge on how to do this sort of thing is never a bad thing, and two, if you try to do something where you would be generating a 3D model in GameMaker yourself, for example, a terrain editor comes to mind. That's something that I did recently in one of the tower defense videos. Or if you're trying to create a 3D object from a vertex buffer at runtime for some other purpose, you will probably want to know how to generate the surface normals for that, and that's what we're going to be doing today. I know I put this disclaimer at the beginning of pretty much all of my 3D and GameMaker videos, but it's going to be especially important today. This is not beginner level stuff. I'm going to be producing this video with the expectation that everybody watching it has a fairly solid grasp of 3D and GameMaker and just GameMaker in general, and computer science and certain aspects of 3D mathematics. If you've watched all of the previous videos that I've made on advanced GameMaker stuff, you should be fine, but listing off the prerequisite things that you're probably going to want to know for this video: basic 3D and GameMaker, obviously, particularly vertex buffers and lighting. Generating surface normals does, after all, have to do with putting data in a vertex buffer that affects the way that it is lit. You're going to want to be familiar with the cross product and certain aspects of vector math in general. The cross product is really the heart of what we're going to be doing here today, and we're going to be making use of some 3D vector functions in this video to make our lives easier. You're going to want to know how buffers work themselves, not only in the vertex buffer sense, but also just in the raw data sense. This isn't critical for generating surface normals, but the way I'm going to be attacking this video is by loading a 3D model from a file into a vertex buffer and doing some operations on that vertex buffer to calculate where each of the triangles within it are located. And from there, we'll be using that to generate our surface normal. I will have links to all of the relevant videos that I mentioned, both in the video description and in a card that should be popping out of the side of the screen. Now, if I haven't scared everyone away already, let's get into this. So a little bit of extra setup. This is the Going Merry. This is the pirate ship from a particular anime that I used a long time ago to test basically 3D object loading into GameMaker in the first place. And today we're going to be bringing it back. The reason for this over some of the other models that I've used is that if I were to open up the model file itself, this is a fairly complicated object with a lot of surfaces pointing in all kinds of different directions that would require their normals to be set correctly in order for you to really be able to make out what it is. This is just the same old basic 3D rendering test program that I've been using since basically the beginning of the series. This is loading Merry.d3d from a file. This is that old load model function. If you prefer to deal in OBJ files and not like the ancient GameMaker 3D model format that I've been using, I've also included an OBJ version of it, although this project does not contain OBJ loading code, so that's up to you. The model itself contains all the vertices in the correct locations, but all of these surface normals are set to, I forget if I set it to 0 or 1. I think it's 1 because 0 would make it unshaded.
Hey.
The point is, the surface normals are, for all intents and purposes, all messed up, and they're not very useful to us. So I'm going to create myself a function, and this is basically the camera step event. Okay, I can probably get rid of all this part where I was messing with the clipping planes, and also the rotation of the object, because we don't need that anymore. And I'm just going to say if keyboard check pressed, let's say vk underscore space. I'm just going to write a function which shall be implemented momentarily. Let's call it scr calculate normals. And this is a function that we're going to write in a minute. This is going to take an input, a vertex buffer as an input, which is going to be VB Mary. It's going to return a new vertex buffer. So I'm going to reassign that to VB underscore Mary. Okay, so let me go and firstly create this function, and I'm just going to call this, what did I call it? I've already forgotten. What did I type into the code editor? SCR calculate normals is what we called it. This is going to take one argument. I'm going to call it VBuffer because it's going to take a vertex buffer. Let us... Where was it? Let me rename that so that we know what it is. We're going to need to do a few things. First, let me maximize this. We are going to need to convert the We are going to need to convert the vertex buffer to a regular buffer. We can do that with var buffer is going to equal buffer create from vertex buffer. This can be the one that we pass in, vBuffer. The type is going to be buffer fixed. The alignment is going to be 1. As always, when we create a buffer, when you're done with this, buffer delete buffer. One of my obscure wishlist items for GameMaker is that we can just have the ability to edit vertex buffers directly without having to do this go-between with the buffer create from vertex buffer, but as of my recording this, that has yet to manifest itself. I submitted a feature request for that a while ago. They said we'll think about it. So, the way that I'm going to do this, I'm going to iterate over all the vertex data inside this buffer, and I'm going to pull the triangle position data out of that, and I'm going to figure out the surface normals based on that triangle position data. This is what I was referring to when I said at the beginning that you're going to want to know about buffers. If you are generating your 3D model through some other means, if you're, for example, if you have a height map and you're iterating over that to build terrain or something like that, this may not be relevant to you. Ultimately, it doesn't really matter how you get the 9 values that are the 3 coordinates of each of the vertices on your triangle, as long as you are able to get them. So I am going to create myself a for loop, as I said, for var I equals 0. I is less than buffer get size. The buffer is going to be the one that we created from the vertex buffer. And I, instead of saying I++, I'm going to say I plus equals 36. The reason for that being in my vertex format over here that I've created that I'm using here, we have a 36-byte vertex format. We have a 3D position, which is going to take up 12 bytes. This is 3 32-bit floating point values. Next, we have a normal, a 3D normal, which is also 12 bytes, and then a 2D texture coordinate, which is 8 bytes, and a color value, which is 4 bytes. And if you add these all up, you're going to get 36 bytes in your vertex format. So we're going to, in each update of this for loop, we are going to actually, instead of updating I by 36, we're going to be increasing it by 36 times 3, because we are going to be working in batches of 3 vertices today. We're going to be working in batches of each triangle in the vertex buffer. So to get the position data out of this, again, the 3D position is the first thing in this vertex format, so it's going to be the first 12 bytes. I can say var xx is going to equal buffer peak inside the buffer. The offset is going to be I plus, and I'm going to say 0, 0. I'm going to type 2 zeros there just so that all of my lines of code line up nice and neatly. And the type is going to be buffer f32. Also, I'm going to name this x1 instead of xx because we are going to be dealing with 3 x's, 3 y's, and 3 z's. Next, we can do this 2 more times. We're going to have buffer peak out of the buffer I plus 0.4 and then I plus 0.8, all 32-bit floating point values. Therefore, each of these values takes up 4 bytes. So the first one is going to be at position 0, the second one is going to be at position 4, the next one is going to be at position 8. You can think of I as the starting index of each triangle in this in each iteration of this for loop. Next, we're going to want to do this 2 more times. We're going to have x2 and x3. And for x2, y2, z2, instead of buffer peak 0, 4, and 8, we're going to buffer peak at 36, 40, and 44. And for x3, y3, z3, we're going to buffer peak at 72, 76, and 80. So if I is the address of each triangle in the buffer, I plus 36, I'll start at the beginning. I plus 0 is the address of the first vertex in the triangle. I plus 36 is the address of the second vertex in the triangle, and I plus 72 is the address of the third vertex in the buffer. And in between here, there would be other data such as the normals themselves, whatever they happen to be, the texture coordinate, the color, any other information that you decide to attach to the vertex buffer. Okay. So this is our triangle data. Again, if you're generating the 3D model that you want to calculate the normals of through some other means, you may have vertex data obtained through some other means, and you may not be reading it out of a buffer like this. But I'm going to be honest, if you've gotten this far in 3D and GameMaker, I have the expectation that you don't need me to explain this to you. So how are we going to do this? So if you want, you can do all the math by hand, which will give you the right answer. I kind of don't recommend doing that because it's going to just involve a lot of typing and a lot of spaces where you have the potential to accidentally introduce errors to your code. As a general rule, when you're doing 3D in GameMaker, it's probably not a bad idea to have something resembling a 3D vector library that you've written. I'm going to go and create myself a new script. I'm just going to call this vector3, and I'm just going to copy and paste this in. This is a somewhat cut down version of the vector code that I've implemented in the 3D collision series that I'm doing. It's got a bunch of other functions, but we only need the 4 that I've got on screen right now. Subtraction, cross product, magnitude, and normalizing. Okay, so now that we've got our vector library, I am going to start to use it. So I'm going to take each of these x1, y1, z1, and so on, and I'm going to convert these into just a couple of vectors. I'm going to call them var v1 is going to be a new vector3. This is the first vertex. This can be x1, y1, z1. Var v2 is going to be x2, y2, and z2, and var v3 is going to be x3, y3, and z3. So we're going to be taking these coordinates, turning them into vectors. Next, we don't care so much about the absolute positions of these vertices in 3D space as we care about the vertices' position relative to each other. So I'm going to say var e1 can be equal to v2 dot sub v1, and I'm going to say var e2 is going to be equal to v3 dot sub v1. I was just thinking I haven't screwed up the position of my hands on my keyboard all video, and then right there I just went and did it several times. Like when I was typing the word subtract there, I had my right hand shifted over one row on the keyboard or something like that. I guess if you want, you could also say v1 dot sub v1, but as we all hopefully understand, this is just a 0 vector. This is just going to return a vector3 that's got 0, 0, 0 in each of its components. So we don't really have to concern ourselves with that. This is the position of v2 relative to v1, and likewise, this is the position of v3 relative to v1, which is really all we need right now. Next, let's start doing the cross product. So I'm going to define myself another value. This can be, let's say, var norm, because we're going to be actually getting to the normal here, is going to be equal to e1 dot cross e2. This is going to be the cross product of e1 against e2. This is going to produce a vector3 that is perpendicular to both e1 and e2. As far as we're concerned, that is the normal of the triangle. However, this thing could have a magnitude of pretty much anything. This isn't guaranteed to have a magnitude of 1. And it's not required, but generally when you're dealing with surface normals, you want the magnitude of that vector to have a magnitude of 1. And to calculate that, we can say dot normalize, and we can normalize this vector to ensure that it's going to have a magnitude of 1. If the triangle that you're calculating the normal of here has a surface area of 0, which is to say that, for example, all of these vertices are in the same coordinate, or if all these vertices are in a line or something like that, and the triangle has 0 surface area, then the cross product is going to return a vector which has a magnitude of 0, which is 0, 0, 0, essentially. And when you try to normalize that, you're going to get something that's rather undefined. And depending on how you're calculating these vertex positions in space, that may or may not be something you need to worry about. You may want to do a check to see if the magnitude of this cross product is equal to 0 or not. But since I've pre-created the 3D object that we're going to be setting the normals of ahead of time, I can guarantee you that we do not have any triangles with a surface area of 0. And this will not be giving us any trouble. Next, we have our surface normal. We need to get this back into the vertex buffer somehow. You could, if you wanted to, you could create a new vertex buffer from scratch, and you could populate the values in there. To keep this video somewhat simple, I'm going to, instead of doing that, I'm just going to actually, I'm going to actually poke the data back into the vertex buffer, and I'm just going to recreate the original vertex buffer from that. So instead of assigning values to each of these positions, we can say buffer poke. Let me just update all of these function names. The buffer is going to be buffer. The offset is going to be, instead of I plus 0, I plus 4, I plus 8, because these are the positions of the vertices in this vertex buffer, we're going to instead want I plus 12, I plus 16, and I plus 20 for the normals of the first vertex. We're going to want I plus 48, I plus 52, I plus 56 for the addresses of the second vertex, and I plus 84, I plus 88, and I plus 92 for the addresses of the normal in the third vertex. And the type is going to be buffer F32 because normal vectors are like positions, 32-bit floating point values, and the value itself can be norm.x, norm.y, norm.z. Since we are doing flat normals today, this is going to be the same on all three vertices of this triangle. If you wanted to do smooth normals instead, you would have to do a little bit more work so that you could smooth out the normals based on their neighbors, based on the normals of each vertex's neighbors. Or maybe I should say based on each triangle's neighbor, anyway. But flat shading, each vertex is going to have the same normal within the triangle. Then, let us, outside of this loop here, let us turn this buffer back into a vertex buffer. I'm going to call this var updated vertex buffer is going to be vertex create buffer from buffer. The source buffer is going to be the one that we have been working with. The format is going to be, I've hard-coded this to be a camera.vertex format. Like that. People who like software engineering may not consider this to be very good code, but it'll get the job done for this tutorial. And lastly, we need to return the updated vertex buffer. And that should complete this function. When we hit the space key in the step event, we are going to be recreating a new vertex buffer, which calculates the normals for each of the triangles inside the vertex buffer, and we're going to be resetting this to the new one. I guess. Do we want to also delete the original one? Would that be like, since we're technically losing the reference to it after this, vertex delete buffer, like that. So now if I run the game, there is a 50-50 chance that I have spectacularly done this correctly on the first try, versus that this is going to spectacularly blow up in my face. And if I hit the spacebar, we can see that the lighting is correctly calculated on the Going Merry. If you imagine this shader as a directional light that's basically more or less pointing in the direction that I'm looking right now, the triangles that are facing me are in full sunlight. The triangles that are facing away from me on this side, for example, on the back of the flags, those are mostly in shadow. The ambient light is rather dark. Let me just for the sake of making this look better, let me edit the shader and let me instead of. Okay, there we go. Now we have a bit of a dark gray ambient color on the unshaded side, so that it's a little bit easier on the eyes that way, I think. So that is how you calculate the surface normal of a triangle. Again, in some situations you may want to, instead of doing flat shading on these triangles, you may want smooth shading. And I will be talking about how to do smooth shading in a future video. That is a little bit more involved because in that case, the normals of each vertex in a triangle will not all be the same, and they will instead be somewhat influenced by the other triangles around them. But that's a story for another day. If you want the code for this, look for the GitHub repository down in the video description. Otherwise, I try to post about 2 game dev videos a week. I like talking about somewhat more obscure subjects in GameMaker, such as this one, so if that's the sort of thing you're interested in, feel free to subscribe. I have a Patreon, so if you want to contribute towards these videos being made, there will be links to that in all the usual places. You could see your name in the credits, or hear yourself shouted out at the end, see a preview of my future plans, that sort of thing. Otherwise, I hope you all found that useful, and I will see you all later. Special thanks to Edward Holt, Emily Koyo, Gunnar Clovis, Poshar, Sindra Larson, Squarecrow, Tusk, and Zenjamin for supporting these videos. If you want to see your name in the credits or hear yourself shouted out at the end like this, head on over to the Patreon page down in the video description to join the fun.